Um, I'm hoping this talk will take about somewhere between 40 and 60 minutes, and it won't involve me droning on too much. So talk is titled Prove Your Code Works, a Path to Professional Software Development. I suppose the talk comes from, I don't want to say 15 years of frustration, but maybe mild disappointment in areas, and a feeling that maybe certainly in the last 10 years, the last decade of my professional career, that I've not seen the progress in the industry, in the tech industry, I hoped for. Like sort of back in 2005, when I was a very young junior developer with no cares in the world and no money, things were a bit, loose and a bit fast, but it just felt like the industry was getting off the ground, and that was the way things were done. And then over time, things would improve as the web development industry got better. But I wonder whether that has happened and whether it will happen. And this talk really is about a way of defining a sort of a professional approach for development. The basics, basically, will cover the basics of professional development. So let's dive in. So a little bit about me. I know I've mentioned this before. I'm Rob. I live in Aylesbury in the UK, which is in Buckinghamshire, which is if I remember, northwest of London, about an hour from London Marylebone. I've done all sorts over the last decade or so. I've obviously been a developer, rising from junior up to senior. I've been a manager, so I was a head of tech for a while, and currently I'm an architect. My main two languages over the last decade have been PHP and JavaScript. I did start with a bit of .NET, but the thing I'm getting into at the moment is Rust, which I think is possibly the best thing. I don't know. It's just brilliant. I really like Rust. If anyone wants to learn a new language, definitely have a look in Rust. And there will be a little bit of Rust in this talk. So a couple of things I do. One of the things that is relatively successful is really simple JWTs, which is a PHP library for implementing JSON Web Tokens. You can easily implement it in things like Slim and various other frameworks. Just a very simple approach to it. And a new tool I'm working on around content security policies. You might notice a theme here. I'm quite into sort of security software. Is a tool I've built in Rust called CSP Generator, which is about like building content security policies, making it a bit easier. So I'm doing quite a bit of work around that. I did speak here at PHP Hampshire last year, and last year I had none of these things. I didn't have a home that I owned. I didn't have a baby, and I didn't have two cats, and now I have all three things, and my life has been turned upside down in a good way, but it is a bit crazy. So what's this talk going to be about? It's going to be about professionalism and software development, and this is a vast topic, so I am not going to cover it all. I am going to cover a very specific part or a small area of it. There's a huge amount related to professionalism that needs to be covered. For instance, I won't be looking at the topics of management or planning, which have an enormous effect on how we as developers and other roles in the tech industry can be professional. With all the best will in the world, we can try and be professional, but obviously management and the planning process can completely screw that. The old deliver tomorrow sort of approach, or deliver yesterday or last week or whenever it was. That can mess with our approach to being professional. But I'm not going to talk about that because I think A, it might make me upset, and B, it is in itself a huge topic. So when we talk about professionalism, what do we mean? We basically mean two things. We mean, expertise, and as my Shutterstock image suggests. We have an expert helping an old man with something, hopefully as a doctor. But expertise is not what this talk's going to be about, because all developers to varying degrees have a level of expertise. Like, you know, you have to be some sort of expert to be a developer. You can't not be an expert. So we're not going to talk about expertise because I'm going to assume that's a given. So I'm just pushing. Going to talk about is guarantees. Okay, what as developers for our work, and this is similar to the way a doctor provides guarantees, or an accountant, or various other professionals. And it can be things like certifications. So doctors will have all sorts of certifications to prove that, for instance, if they're a surgeon, that they can cut you open and you won't bleed to death immediately, right? And an accountant will, you know, provide, you know, again, certification to prove, and references and various other things to prove that they will do your accounts accurately and won't get you in trouble with the tax man. You know, that's what I hope from my accountant. So what I'm trying to look at is what guarantees we as software developers can provide to the users of our software and the clients and various other people. They're sort of like the contracts on the interfaces that we love to talk about so much. But one thing to start with, right? Being professional does not equal good, right? It's not, they're not the same things. And this isn't a talk about being a good or a great developer. I don't regard myself as a great software developer. Great software developers exist. We probably all know one or two of them. They're probably on Twitter. They probably build tools like Xdebug and various other things. You know, they build Composer, and they're very clever guys. They're the great developers. I'm not one of those developers. I sort of dabble a bit. My focus is trying to be a professional developer and trying to provide a base standard for my work. And I'm interested in the ideas around how we make our industry better generally, and how we improve generally, not how we all become, you know, great at software development, but how do we generally become better. But this, I don't want people to think that being professional is boring and you won't achieve stuff, right? As professionals, like, you can succeed at what you do. And I don't know, obviously a lot of developers aren't necessarily into sport, or particularly football. I am a massive football fan, and this whole like no football period of time is awful. I have nothing else to talk about apart from software, which is just diabolical. But there are good examples in football of professionals succeeding. The chap we see in the image here is James Milner. Now, James Milner is not a great footballer. He's not the Lionel Messi or Ronaldo of his generation, or the Zinedine Zidane of his generation. But James Milner has built a career around being very professional, a very professional footballer. He trains incredibly hard. His work ethic is great. He does whatever he's asked to do on the pitch. And as a result, he's still regarded as one of the fittest footballers in the Premier League, even though he, in footballing terms, is now 34 and therefore regarded as ancient. He is younger than me, though, which should tell you a lot about me. But he has succeeded in his career, and he's had great success, and he's enjoyed, well, in many respects, a glittering career. If we look at his trophy cabinet, he's pretty much won everything an English footballer could win. He's won, we'll call it 2.5 Premier Leagues, because Liverpool are top of the league, but it's been cancelled. He's won an FA Cup, he's won the League Cup, he's won the World Club Cup, he's won the European Super Cup, he's won the Champions League, and he's won a Community Shield. There's probably only one other trophy in Europe he could win, and he'd have won everything that he could have possibly won. So he's just been a professional, right? And he's worked hard, and he's had great success. And that's the thing here, like we're not all going to be great developers, but if we're professional, we can actually succeed, succeed and achieve a lot, really. But there is a big question to answer. And for me, this is the important question. Is the tech industry professional? Like, is it a professional industry? If we compare it to other industries, how do we stack up? Now, there's lots of ways we can look at it. We can look at the hard evidence, the facts, but before we do that, we'll have a little jaunt into some of the anecdotal evidence about the tech industry. So I've been obviously perusing Twitter a lot recently, and we have some great ones. Describe software engineering in 3 words or less. And Akramius comes up with, we'll fix later, right? I think everyone has heard that one and feels for that. We then have this one, every other line in this legacy code base that should never have been written. Brilliant. And then this one came up today, and I love this. This is great. Every single code base. And there's a lot of anecdotal evidence to say that, like, are we doing a great job? Are we doing a professional job? How well are we performing? If you look at that picture closely, it's quite funny, actually. There is a little string there that looks like it's for keeping things level. Like, so maybe that wall design is deliberate. It might not be a terrible build. These builders may be just showing off their skills. And then there's other aspects of this, right? So we read a lot about, as developers, about things like this. Like, basically, how do we do our job faster, right? How do we become quicker at software development? And for me, this is really problematic, because, yes, we all want to set up our working environment so that we feel comfortable and efficient. But being fast and delivering quickly is not our primary goal. Our primary goal is to deliver good functioning software that is reliable. How fast we do that is, obviously can't take forever, but it's better to be reliable than delivered as soon as we possibly can, because as most of us know from experience, the faster we try and do something in software development, the more likely it is to go wrong. So that's the anecdotal stuff. But then if we look at some of more of the harder evidence that's out there, it doesn't look necessarily great either, right? So everyone will know about British Airways, or I hope they would know about the British Airways incident, where they've basically been fined £183 million for breaching GDPR. And this came down to basically a cross-site scripting attack, which was based on the fact that they hadn't implemented a content security policy for their website. And they got fined £183 million. And we know how these situations occur, right? Because things like security get pushed to the bottom of the priority order, and stuff gets rushed out without fully thinking it through. Like, they've rushed out a change to the JavaScript dependencies, and they didn't have any content security policies in place, so £183 million fine. Things don't look great, and this is only one example. There's loads of examples of stuff going wrong in the tech industry. More recently, you could now see the code for the COVID-19 model that powered the Imperial report that sent us all into lockdown. Now, obviously, lockdown was the right thing to do, and is keeping us safe. I think we can generally all agree on that. But if you actually look at the software that ran the model, it's unbelievable. What you see in the background is some of the code, and it's just thousands of lines of code like this. Essentially, there would be no way of proving that this model actually functions as anyone expects. Like basically, the implementation of the underlying mathematical model is correct, but it's powered one of the biggest decisions in UK history. And there's some, I imagine in the future there'll be some serious questions asked about this model and about this code, and how we ever allowed a decision of the magnitude that was taken to rest on code that looked like this. And I mean, who knows whether it works or not? I mean, I don't think you could actually prove it works. Definitely take a look on GitHub if you want some fun looking at some C++ code. So let's look at another industry. So the picture on my right is a picture of me when I was a little boy, and the man sat next to me is my father. My father was a carpenter, and he spent many years in the building industry. I think before he retired, he'd done about 40+ years. And he worked from the bottom right to the top. So he started as a carpenter, and then he ended up as a planner. So coming up with tenders for huge sites and stuff. And he knew the building industry inside out. And, you know, as anyone who's close to an industry, you know, for a long time, they obviously have their gripes and complaints. And my father spent a long time, or not a long time, but has complained to me a lot about how, you know, the building industry performs and how it's corrupt and all these various things, right? That's terrible with it. But if we look at it compared to the tech industry, the building industry feels, well, the tech industry feels in comparison to the building industry like the Wild West. If you want to build a house in this country, and you can't just build a house, right? You can, though, just spin up an AWS instance and start collecting people's data, do whatever you want, right? Even though there's GDPR and cookie policies and what have you in place, you can basically do what you want. Whereas in the building industry, you can't. If you want to build a house, you have to go through a design process with an architect. You then have to get planning permission. You then have to get building control approval. You then have to acquire some insurance to do the build to make sure that if you mess up and kill someone, everything's insured. And then you have to go through the process of building the house, which requires you to employ, you know, skilled, qualified laborers, you know, carpenters, bricklayers, electricians, plumbers, various other things. And they all have to be qualified now. You can't just turn up and become an electrician, thank God. And then once you've done all that and the house is up and standing, you have to get what's called a completion certificate. And that's where someone signs off the house and says, you know, someone independent comes along and says, okay, yeah, I'm happy with the house and everything. It looks like you've got everything in order. It's habitable. You can live in this house now. I mean, who does that in the tech industry? No one. A completion certificate. Imagine that. Imagine management having to cope with the idea that they had to have software signed off before they rushed it into production. It just wouldn't happen. So if we ask that question again, is the tech industry professional? The answer is it no? Maybe it is no, right? Maybe the answer is no. And I don't want to be too down on this because I hope this talk becomes quite a positive thing. But there is a serious doubt about how professional the tech industry is. Maybe it's not. Maybe it isn't a very professional industry. I'm sure that there are people and companies out there, and I don't want to anyone think that I think developers ever act in bad faith. I think developers try and do the best job they can given the situation they're placed in. So how could we improve the situation as developers? How can we make things better? Okay, one thing in my head that I think we can do to make things better is to prove our code works, or prove your code works. The code you write, provide some proof that it works. Like other professionals do, provide some guarantee that the thing you've produced or you're producing is going to work and be reliable. So how do we do this? Well, there are 3 parts: documentation, tests, and analysis. And ultimately, all this comes down to is badges. We can put badges everywhere, and everyone loves badges to prove that what we've done works. Now, before we get into the nitty-gritty of these 3 areas, there's a topic that links all this together, and that is, and I think this is something of real importance that not enough developers know about in my experience, which is this concept of observability. And you see observability everywhere once you understand it. But observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs, right? And all this means is how well can we understand a system without looking inside it? Like basically, how well can we understand a car engine without lifting up bonnet? And in terms of code, it's a similar principle. What information can we surface? What metrics can we surface about our code that allows people to verify its quality without actually ever looking at the code, right? And lots of people already do this, right? So it's not a new thing in code. I think it's much better done in the open source community than necessarily is done in the commercial sector. But that's what we're trying to do here. When we say prove your code works, we're talking about observability. How can we increase observability of our code, right? Because not everyone who's going to look at our software or use our software is going to be a technical expert who can look at the code and validate it's good, right? So if we can improve our observability, we help them, you know, we can guarantee to the layman that the stuff we're doing is going to work. So the first bit, documentation. Right, there was a great tweet the other day, which I really liked, and I only got three tweets, like three likes, sorry, which was, the project's not finished until the documentation is done. So maybe after this talk, go and find this tweet and give it a little like, because I really like it. I think this is the key, and I think like documentation is the one thing in the tech industry that is like, I don't know, the poor brother or something. It's just left and forgotten about, and we don't really do a lot with it. We don't do enough documentation. But there are simple things we can do to improve this situation dramatically and make things better, and to prove, you know, help prove our code works. Because I think documentation is a key part to this, because you're going to surface a whole bunch of information about your code base in your documentation. So the first thing we can do is write a README. And this is the README for the open source library I maintain. And basically, in this, we can surface a huge amount of information that will allow a user or a developer to use the software without ever looking at the code. And you see this all the time. Like, you see languages with great documentation. PHP, actually, despite its many detractors, has great documentation, right? I've never looked at the internal code for PHP. I just look at the documentation on php.net. I hope it's php.net. And the same with like Laravel's success, right? Honestly, I think Laravel's success probably over against Symfony has a lot to do with the fact that Laravel's documentation is very, very good. Obviously, Symfony's a beast as well, but Laravel's done well, and I think a lot of it's to do with its documentation being very accessible. So if we're to produce a README, like, there are basic things we need to get in there. So obviously an introduction, and this should be like introducing your piece of software, like what its intent is, why it exists, and any sort of additional useful information about the subject matter that it covers, right? Then there's installation and setup, right? How does someone start using this? How do they get it installed? How do they get it working? And then a basic usage example, and that's part of the getting it working process. Like, provide an example of code that implements everything and gets it working, so, you know, it can be done very simply. And then get into the topic of advanced usage. And that should cover, like, basically all the interfaces, all the public interfaces that your software provides. You should have some documentation on, and some usage examples. And then, of course, badges, right? Some badges to show how your code is performing. On my one, I've got my build pipeline passing, I've got my code coverage, mutation score, which I'll get into, style CI, and then some other information, like, for instance, that The library currently only works with PHP 7.2 or greater, so you know that, that's useful information. And actually the downloads, which gives some, you know, obviously it's like, you know, bit of PR, bit of showing off, but it does prove that other people are using it and they're finding it reliable, right? So that, work on a README and get this going. And if you can get this basic information out there, particularly on commercial projects, like when it comes to handover or a new person joining the team, they will be able to pick up your project much, much quicker. Okay? Now, comments. Comments is the thing that people really hate. Don't like comments, don't like writing comments. You see loads of code across the board that doesn't have comments. So in this case, we have a class called travel, and we have a function called total cost. And it has an integer going in called outward and an integer going in called return, and it basically adds them two together to get the total cost of a journey. Now, in many cases, some developers might assume that this code doesn't need a comment, right? It's obvious, right? It's obvious what this does. It does a calculation of a total cost of some sort of journey, right? So you'll either see no comment or you'll see a comment like this: add outward to return. Comments like this are useless. Like, don't write them. There's no point. They won't help you. They won't help anyone. They're not telling you anything more than they can see in the code. But you should remember there's lots of hidden information in a method, right? Just because you've got quite a reasonably clear method signature doesn't mean that it's abundantly clear what's going on here and what's involved in the domain. So what we need to do is try and express a couple of things: A, the intent of the code, and B, any hidden information that's not obvious in the code in the comment. So a slightly better comment would look like something like this. And I'm not saying that this is a perfect comment, but basically the comment reads: calculate total cost of train journey. Values are in pennies or cents, right? And this does two things. Firstly, it tells us a little bit more about the domain that's going on. It's actually to do with a train journey. We're calculating the total cost of a train journey. And that's important because train journeys tend to have returns, outwards and returns. And then an even more important piece of information that's not obvious in the code is values are in pennies or cents. Yes, we know they're integers, but it's not obvious that we're doing a calculation of pennies or cents, right? With it being PHP, someone might assume we just messed up how we implement floats, right? And you know, that could be a legitimate thing we've done, but this comment makes things a bit more clear. And writing comments has a useful side effect, right? Especially when you're doing the first run of writing some code. If you go through your code and try and explain it with comments, you start to learn the domain a little better. And you start to be able to understand the domain of what you've written. And we've highlighted something here in this comment about train journeys. We've put this function in a class called travel, right? Which is just really generic and doesn't really mean anything. Maybe this function should sit in a class called train journey, right? Because it's the total cost for a train journey. It's not the total cost for travel, right? That could be any type of travel. That could be air travel, whatever. And writing comments helps you through that process, particularly when it's your first go at writing something, because the first time you have a go at writing some code and learning and understanding a domain, it really isn't easy. Okay, so try and write comments and try and make them useful, and think about what is the intent of this code, and is there any information that's non-obvious, right, that I can surface, so that developer in 6 months, whether that's you again or whether that's a couple of teammates or a new member of the team, it gives them a helping hand to understand what's going on in your code. So the final bit of documentation is this number 3.0.2. Now, many of you will know what this, I hope some of you will know what this is regard to. It's in regard to semantic versioning, right? So semantic versioning is a simple format for tagging your code for release. And really what it is it's a means of communication. It allows you to communicate with the outside world via numbers, with these silly little numbers, what is going on with your project and what you're doing with your project. And basically it follows a simple pattern: major, minor, patch. And what this means is a major release is that you're definitely going to have backwards compatibility issues, that you're basically breaking stuff. A minor thing means that you're adding functionality in a backwards compatible way. Like it will continue to work even though you're adding functionality. And a patch is basically a bug fix, and that could break backwards compatibility, but you have to release this patch because it might be a security hole, it might be a major issue with how things function, right? But what this does is if you use this approach of SEMVer or semantic versioning, you're basically communicating with your users and anyone else who needs to know this information. Like even if you're working in a team of teams, like in a department with many teams in it, and you're producing a service and you do a release and you're just doing what I've seen teams do, which is just increment a number, like going 1, 2, 3, 4, 5, that communicates nothing to the other teams about what's happening with your project, whereas SEMVer does, right? And if you combine that with some release notes, you then have a history of your code, you know what happened when, you know if a change was a major release, if it breaks everything, right? So SEMVer is really important, and it should be something you should look at because it's a great way for communicating what's going on in your project, and again, providing observability and some proof that you know what you're doing. A good talk to watch is Marco Pivetta's talk on backwards compatibility. Marco works for Rove, and he's recently I think it was last year at Dutch PHP, did a great talk on backwards compatibility, which is a monstrously complicated topic, and you won't get it perfectly. You won't perfectly align backwards compatibility with SEMVer, but obviously you're trying to communicate when you're making a breaking change. So that is documentation, right? And I think if you can do more documentation, you'll surface a lot of information that will give people more of an insight into your code. The next thing is tests, right? And we're going to focus on unit tests because that is the core of what developers will have to test, right? There are many other forms of testing, and testing is a huge topic, but unit testing is basically the bedrock. And a unit test is just a small test which tests an equally small amount of business logic, right? And business logic is really important to this, right? So when you do your unit test, you need to focus on business logic, and we'll get into that in a moment. Many of you will have seen the testing pyramid. Essentially, all this means is that unit tests, you will write a lot of unit tests, and their cost of running basically should be low. So you should be able to run lots of unit tests very fast, which means they should run against very small amounts of code. And then you've got integration tests and functional tests, and there's about 1 million versions of the testing pyramid showing different names for different tests. So like this is my version of it is not complete, but basically unit tests at the bottom. Unit tests rest on a concept called code isolation, right? And code isolation is something that I could give a talk on. I'm going to cover it in about 3 slides, but it's a massive topic and a really important topic. I will touch on it again later in this talk, but basically code isolation means this. You have 3 rough rings if you're building in a framework like Symfony or Laravel. You have your input-output, which is dealing with the Great Wide Web and databases and the file system and various other things. That's your input-output. You'll then have your framework code, which will give you loads and loads of tooling, often to deal with input-output stuff. And then you have business logic. And business logic is the code that you write that is basically your value proposition when you write piece of software. It's your thing, okay? And this is what you unit test. You try and avoid unit testing the framework. You want to avoid that because you'll get complicated, and you try and definitely avoid testing input output. because it will just make testing impossible. Just don't do it. Focus on business logic, right? And there's a code example I'm going to try and give that will show you this in 3 slides. So code isolation is basically about removing the framework and any input-output from your code. So in this example, we've got a silly function that looks at some file and says, has it got a lot of content in it? And it returns a Boolean, basically true, false. So it goes file get contents, and it's going to look at Google, and it's getting the content for the Google homepage, and then asking a question: is it greater than 20,000 characters in length? This is, this is terrible code. You've mixed IO right in there. You've also mixed your, your runtime stuff with the google.com right in there, right? So we don't want to do this, even though, there's seen this plenty in my career, and I'm sure many of you will have seen similar things. So a smart developer might think, okay, well, I'm going to remove the google.com string and pass that in. So we'll get something like this. So we'll now pass a file name in so that we can look at any file name or any file anywhere on the internet with file get contents and check its length. Again, this is no real use to you because ultimately we're still mixing IO with our business logic. Our business logic is the string length greater than 20,000. That's the thing we're interested in, right? We're not interested in how we go and get the file, the contents information. That can be done in various ways through a framework, whatever, right? What we want is to be able to isolate our business logic. So what we need to do is take it a step further. And instead, we just have a primitive type of string, which is a content, and then we run our business logic against it, okay? Yes, we said file has lots of content, so we've given it some domain, but ultimately we've isolated our code. And this is important because we can now easily test this, right? Beforehand, when we've got file get contents, our unit tests rest on the assumption that we've got a file system and we can access that file system. We might not be able to access that file system, so our unit tests won't run, and they won't run easily. Whereas in this example, we've isolated our code, we've removed the input-output, and we're focused purely on our business logic. And then we can write a whole bunch of unit tests, very simple unit tests, to make sure that this works as expected. We can run a bunch of scenarios against it and build up reliability quite quickly. So if you're going to do unit testing, think about your business logic. Well, actually, do unit testing, but think about your business logic and think about this concept of code isolation, okay? Because it will make your unit testing much easier. You will find unit testing hard if you don't isolate code. So the next step in this, particularly in regards to proving our code works in terms of unit tests, is to do some code coverage, right? Write some code coverage or run some code coverage reports. And for those of you who haven't dealt with code coverage before, basically all it's doing is telling us how much of our code is covered by unit tests, okay? And on the left, we can see an example of this. I know this is from the Coveralls website, and this is their interface for a code coverage report. And basically, the stuff in the light green is covered by tests. So we know that this code has a test so that we know it's a bit more reliable. And the code in red hasn't been covered by a test. So basically, the pass through this code, the bit in the code where it's got the catch, that hasn't been covered by tests, right? So that, again, less reliable. We don't know, we can't prove that works. And obviously, we produce code coverage scores and we produce code coverage reports that are very useful and tell us where we need to improve our testing. And there are plenty of tools out there that you can use. There's codecov.io and there's coveralls.io, which will help you produce these tests. Now, there is a slight controversy around code coverage, and some developers approach it. They don't like the idea of pushing for 100% code coverage. And the reason they don't like this is because they claim that you can game code coverage reports, basically, as in you can write a whole bunch of happy path tests that don't really test your code, but do cover it and will bump up your coverage score. Now, for me, this is a bad way of looking at things for two reasons. First, because the first reason is because we can solve that problem, right? And I'm going to jump on to solving that problem in a moment. But the second problem I have with this approach is it assumes bad faith on the developer's part, right? It assumes that developers are going to deliberately write bad unit tests just so that they can bump up a code coverage score. And we know that that doesn't happen. Developers don't work in bad faith. Developers often work under far too much pressure and don't have enough time to do the work they need to do, you know, in the time that they've been arbitrarily given. And they're not acting in bad faith. So they might, and also ignorance, right? A junior developer might get some tests wrong. They might not write the best unit tests in the world, and therefore their code coverage scores might not be the best. But I don't think we should assume developers are working in bad faith. And really, 100% code coverage is not an end point. It's a starting point. Once you get to 100% code coverage, then you need to ask a whole bunch more difficult questions. But 100% code coverage is a great point to get to. And of course, once we've done this, once we've got some code coverage scores and we're producing some code coverage reports, we can add more badges. We can put more badges on our project, on our README, and display to the world how good our code coverage score is. So I mentioned briefly, like, how can we get around the issue of bad unit tests that produce code coverage but don't actually test our code properly? Well, there's a thing called mutation testing, and this is something I would encourage any developer who's doing unit testing to do. Mutation tests are amazing, and they help you improve your unit tests immeasurably. They've helped me, yeah, they've made my code so much better. So what are mutation tests? Mutation tests are a form of what's known as fault injection. And fault injection is where you edit code to try and create bugs. So you run a program that tries to create bugs in your code. And the aim being that you're going to cause a bunch of tests to fail. Now, in the scenario with mutation tests, failing tests are a good thing, right? You don't want tests to pass. If someone injects a fault in you to pass, your tests are failing, basically. They're not doing their job. They're not doing the regression testing bit where they're actually revealing that so-and-so in team B made a change to our code and it broke everything, right? You want tests to reveal that. You want tests to break when someone makes a breaking change somewhere. And mutation tests can help guide you to a point where your tests will fail in the right scenarios. So you will produce more effective tests. And out of this, you'll get something known as an MSI score, which is a mutation score index. And the higher this is, the closer to 100% this is, the better. And what this means is also that if you've got this in place and you've got 100% code coverage, you can be sure that your unit tests are working well, right? Your MSI will be lower if your code coverage is lower, right? So this works hand in hand with code coverage. As you move up your code coverage, your MSI score will get better. And there are some useful tools out there. There's Infection PHP for the PHP developers, and for JavaScript, Scala, and I think it might be Go, there's a tool called Striker. Striker is monstrously complicated. If you want to get into mutation testing, the documentation on Infection PHP is actually very good. Well worth a watch. Well worth a read, sorry. I think I said watch because obviously I've been watching The Witcher recently, a really good show. Watch The Witcher if you haven't seen it. He's a mutant, but very cool. And then finally, we get more badges. So we can add more badges to our README that I showed you earlier. It's all about the badges and increasing the observability. So how do mutation tests work? Like, here's an example, right? So we have a function, has a dozen eggs, and it returns true if it's greater than 11, right? So a dozen is 12. If we have more than 11 eggs, we have a dozen eggs, right? So we then write a pseudo test. Now this PHP that I've written under the test has a dozen eggs doesn't actually work, but you understand the point, right? So we're going to set eggs equal to 15, and then we're going to check, we're going to assert true, has a dozen eggs, and pass 15 in, and it's going to assert true, right? We know because 15 is greater than 11, so it's going to pass. We've got a working unit test. Along comes your mutation test, right? And they inject faults into the code, and then things start to go awry. So the first mutant that gets created is that the before our method has a dozen eggs was eggs greater than 11. The mutations come along and said, well, we're going to change it to eggs greater than 12. And then it's going to make another mutation. It's going to say eggs greater or equal to 11, right? So in this case, the first one we changed the number, in the second one we changed the operator. And what will go wrong here is our test, eggs equal 15, will now continue to pass. It will also pass these tests, right? Because 15 is also greater than 12, and it's also greater or equal to 11. And this means we haven't got robust tests. So we need to start writing tests that will fail, right? That will work properly. So a test that would fix the greater or equals operator mutant would be to write a test where eggs equals 11 and we assert false has a dozen eggs. So we check that if there's only 11 eggs, we get a return false. And then that has a dozen eggs mutant will disappear. It will be caught rather than escaping. That's where the whole mutation, it's about mutants escaping or being captured, right? In this case, we've now, by writing this test, we've captured a mutant because we've generated, ironically, a failing test under mutation, under fault injection. So that is testing. So basically, write some unit tests on your business logic, on code that is isolated, work on your code coverage, get that up, and then run some mutation tests. And if you do those things, you'll have quite a bit of proof that your code works, right? You'll have a good test suite, and you'll be able to prove that the code you produced actually works. It does what you say it will do. The final part is analysis, right? And this is broken down into a fair few parts. The first bit is code linting, right? Or code formatting. And this is really about professionalism and being able to share code across teams, right? Because we don't want the code that I've written on the screen, right? I've got a class adder, and first developers come along and they've written a function and it's add23 in camel case, and the squiggle bracket is on the same line as the type hint, and there's no space between the 3 and the number. And then developer 2 has come along and they've written it in snake case, I believe, and they put spacing in different places and it's all over the place, right? Now, if you had a whole project that looked like this, where every developer was just writing code however they felt comfortable with whatever level of indentation they wanted, it would be a nightmare. You'd hate it. So code linting is just basically a very simple way to solve that problem, and it should be implemented as a standard. It then makes, and there's no right or wrong linting, right? There's loads of linting. You know, there's tools. There's PHP Code Sniffer. If you're writing JavaScript, there's ESLint, and then there's loads of standards that you can comply with. So in PHP, there's PSR 12. There's also, I think there's the Doctrine standard. And then there's various other standards, and then in ESLint in JavaScript world, you've got escaped me now, but there are a number in JavaScript as well. I'll remind myself at the end of the talk on what that standard JS actually is one of them, right? So there's loads of different code formatting and linting tools out there that you can use to just get everything aligned and make it easier for developers to jump on board with your projects and with your code. The next one, and this is where it gets a bit more complicated and a bit more fun, is a thing called mess detection. And this is where you run a program against your code to strip out pointless, needless, messy code. So in this case, we have in this code what's known as an else expression error, right? So we've got an if statement, and the if checks if it's a car or bike vehicle, and then says it's a road journey, and then else it's a rail journey, right? Obviously, you wouldn't write this code in the real world, but, you know, to prove a point. The point here is because we're using returns, and returns end the execution of a method when they're hit, we don't actually need the else statement. So we don't need the else expression. So basically, a mess detector like PHP MD or PHP mess detector will tell you to remove it. And it will do, there's hundreds of tests it will run. So it will look at Boolean flag arguments. It will look at unused variables. It will pick out all this stuff for you, all these potential bugs, all these inefficiencies, and make your code more efficient. And this can be really powerful across a huge code base. Like, you can strip out hundreds, if not thousands, of lines of code through this process. So if you can, use mess detection. But mess detection gets even more, well, complicated, right? Now, there's a topic that's similar. I have a passion for this in a similar way to code isolation, which is the topic of complexity. Because as far as I'm concerned, complexity is like the poison or the kryptonite for software development. Complexity destroys everything, and it's the one thing that will kill a project in the end. Like, complexity just gets out of hand. In my career, I've seen things just get to points where code and software is basically unusable. And as a developer, like, one of your primary aims should be to try and minimize complexity as best you can. Now, the positive thing out there is that there's loads of tools to help you with this, and you can automate this. And there are basically two checks you can run. There's one called cyclomatic complexity, and there's one called empath complexity. And they do two very similar things. They do two slightly different things. There's actually a very good talk on this subject by Adam Culp, I believe, the PHP developer. You can look up. I haven't got the link with me, but if you look up Adam Culp, I'm pretty sure he's got a good talk on this issue, on cyclomatic complexity and empath complexity. But basically, all it does is it looks at the number of control structures you have in your code and tells you, therefore, how complex your code is. So control structures are things like for each loops, while loops, for loops, if statements, else statements, and various things. And it will calculate a score based on that, right? But complexity is something that it can hide. It cannot always be obvious that code is actually quite complicated. It can creep into your project. That's why it's a bit like a poison. It sort of seeps in and then gets you, and over time kills you. If we look at this basic method, children above 5 feet, right? So we've got an array of parents going into our method, and these parents have children, and we're trying to work out which of those children are above 5 feet tall. Now, this code looks relatively simple. You know, it's only about 20 lines of code. It's not a huge amount of code. It's got a couple of for each loops that do relatively obvious things. We loop through the parents, then we loop through the children, and then we work out, first of all, the child's height in feet, and then we ask the question, is the child greater than 5 feet tall? And if they are, we add them to an array, and then we return that array, and therefore we get the children we want to who are above 5 feet tall. Now, you could write this code in another way, right? You could write this code like this, okay? So you've basically broken everything apart into separate functions. But I mean, if we look at these two pieces of code, like, that looks really simple. Like, why would we rewrite this code to this? This basically doubles the amount of code we've got. So what's the point in that? Like, surely we've not made things, you know, simpler. But in fact, the reality is we have. And part of this is by asking the right question about our code, but part of it is simply borne out in the cyclomatic complexity scores. The complexity score for this code is 4. The complexity score for this code is 1. And the reason it's only 1 is because basically each method is only really doing one thing. So we've got parents with children above feet. That's a reduction. It does an array reduce. That's all it does. We then have an array filter. All our 4 eaches have gone. And then we do 2 things. We've got is above feet. Basically, we're asking, is this child above a certain amount of feet? And then we do a conversion, a centimeter to feet conversion. Now, the question you need to ask about this code is, prove it works. Can you prove this code works? If I was to come along, if you'd written this code and I asked, can you prove this code works? How would you do that? Well, obviously, you would write some tests, right? So you'd write some tests and then you'd go, well, I've written some tests and I can prove this code works. The problem is that writing those tests for this code is going to be really difficult, because every time you want to test this code, you have to spin up, you have to create the whole parent-child world, right? So you have to create an array and a bunch of objects with parents and with children in to work out whether they're above 5 feet or not. And you'll have to do this a number of times to be able to prove this code works, to prove that your conversion is accurate, to prove that the fact that height in feet will be a float and then you're comparing it against an integer, right? You will have to test all this stuff, but doing the testing for this will be really hard. So what will happen is most likely a developer will write a happy path test and then leave it, or not write any test because it's hard. And a lot of developers get themselves into holes in these areas where they find testing difficult because their code is basically too complicated and it requires too much setup to test. And yes, you can automate some setup in testing, but it's still not fun, it's still not easy. If we go back and look at this code, we can look at 2 methods. We can look at the 2 most important methods, right? The 2 important methods are centimeters to feet, which is our conversion, and the is above feet question, right? Now, these are really simple because they take primitive types only, and they return primitive types, okay? Essentially, we can write, and even though they're private functions, right, you can write some private function setup in PHP to test this. You can then just write loads and loads of assertions to prove that our conversion works really well under various different scenarios. It's really easy on these 2 methods to prove they work. Much, much easier than in the other scenario where we have to create the whole world before we test it. Yes, we will have to test these other 3 methods that are a bit more complicated and require a bit more world setup, but it will be less so because we've proven the core business logic, which we've separated out, which again, we've isolated. We can prove that that works, so that we're less worried about, you know, how we're looping through the code, how we're reducing things and how we're filtering things, right? We can write a couple of basic tests for that, but they're not essential to our business logic. These 2 methods are, and that's the key here, right? And that's how complexity kills you. So if you can minimize and reduce complexity, you will make your code a lot better. And the thing is that this can be automated, and PHP MD has it. If you're doing JavaScript, ESLint has a whole bunch of complexity checks in it, so you can run these, right? And it can guide you to a better place. The only thing to be careful of is the defaults on many of these libraries for their complexity scores are quite high. So in PHP MD, it's like 10. On ESLint, it's 20. You should be aiming for more like 5, right? If you're under 5, you're in a better place than you are if you're, you know, above 5. But I've run this sort of analysis against loads and loads of projects, and essentially I've seen scores well above 50. And for MPath complexity, which grows exponentially, I think I've seen scores of an MPath complexity in the billions, right? Like 9 billion or something ridiculous. So complexity can get out of hand really quickly and ruin your project. So definitely focus on this, and mess detection can help you with that. Got some chat coming in. Okay, let's get rid of that. Where were we? Oh, right. So just finally, like how this grows further, then it could change. Our code could change to asking for children above 5 feet who have hamsters and cats, right? And then it becomes more complicated. But we won't rest on that. Complexity grows very, very quickly. Be careful. The final part of this is static analysis, which is something that's really taken off in PHP recently. And the thing to say about static analysis is all it is basically running analysis of your code without actually running the software, without running the program. You do not run the program, you just run some analysis against your code. And in basic terms, both code linting and mess detection are a form of static analysis. But when we talk about static analysis, particularly in the world of PHP, we're talking about static analyzers. And what we're talking about, what they do is they look at code validity. Like, is this code correct? And static analyzers can be run against weak or strongly typed code, but they are more seen in weak type code like PHP. And they basically do a very similar job to a compiler. They remove a whole range of bugs, particularly based around types. So on the left, what you'll see is some code which is Rustlang, which is a bit of Rust. I promised you a bit of Rust code. And all it is a very simple function. But this code won't compile. And this code won't compile because if you see inside my function, if we have a number greater than 10, we're adding an integer, basically an unsigned 8-bit integer, to a string of 10. And Rust won't allow us to do that. It will complain. It'll throw wobbly. So you can't do that. You can't add a string to an integer. It won't allow it. It basically forces. It's gone now. But it validates the code. It proves its correctness. It imposes its correctness on you, the Rust compiler. Whereas if we write the same code in PHP, and this is roughly as close as we can get to that code in PHP, this will run and execute perfectly well. It will add the number to the string 10, right? And it will do some type casting, type coercion to make that happen. It will assume type inference, basically. It will assume what the type of string 10 is. But that's not great. That will execute. If you run a static analyzer like PHP Stan or Psalm PHP, they're the two popular ones at the moment, PHP Stan will pick up on this issue just like the Rust compiler. And while this isn't the biggest problem in the world with your code, there are plenty of issues where you can misuse types in PHP and cause all sorts of bugs and all sorts of headaches and, you know, basically ruin someone's day. If you use a static analyzer PHP Stan, you can remove all of those bugs. You don't have to worry about them. It will highlight them to you. You go in and fix the code, and then you don't have to worry about them anymore. So you can be more like a strictly typed language like Rust. It won't ever be like Rust because Rust's compiler is ridiculously strict, and it has this whole weird thing around mutable stuff and borrowing and ownership and stuff. But it will get PHP a long way there, and it makes PHP much more reliable. And again, gives some more surety around the quality of your code. Obviously, though, like static analyzers and compilers won't capture every issue, right? So this Rust code will fail. We can cause an overflow error by passing in a number greater than 210, because an unsigned 8-bit integer will only go up to 255. But we can create numbers much bigger than this and try and return them. And the Rust compiler won't pick up on them. You can actually replicate this in PHP. It's that the numbers are much larger because you're dealing with big ints, or no, not big ints, but larger ints in PHP. But the point here is compilers and static analyzers are really useful, but they won't capture absolutely everything. So just remain vigilant. Use them, but remain vigilant. Now, towards the end of this talk, and this is where the positives really start to kick in. Pretty much everything I've talked about, maybe excluding the documentation, but you can also automate some of the documentation. All of this can be automated. All your tests can be automated. All your code coverage reports can be automated. All your static analysis can be automated. All your mutation tests can be automated. All of it can be automated with a CI pipeline tool like Travis or GitHub Actions. It doesn't take a lot of effort to set this up. You can set this up once and you can have it run. And basically, within a couple of days, you can make your code a whole bunch more professional. And you can begin to truly prove your code works. You can say, look, guys, look at all the data we can produce. We can produce code coverage scores. We can produce mutation scores. We can prove that our builds pass, that we've got no failing static analysis checks. All of this can be automated. And this is what I was trying to get at the start, right? Is that if this is like the base level, we can do this. And if we all do this, suddenly everything across the board becomes more professional. And we're all beginning to prove our code works. And then there's more reliability in the industry and there's more faith in our industry. And hopefully things go wrong less. Obviously, there's a whole bunch of issues to fix around management and planning and how we do that and domain discovery and all that complex stuff. But these areas, the things I've covered in this talk, are things that you can look at like tomorrow at work if you're not already doing them. I know many of you will already be doing them, but some of you might not be in a place to do them. But ultimately, there is a business model here as well. So if you're not doing them and your business isn't interested in them, basically, the more you do this stuff, the lower your costs will be. Your development costs will fall because you'll be doing less bug fixing. Less bugs will escape into production and waste everyone's time and waste people's days. Okay, those lost days. And I've seen whole teams lose days to bugs. In fact, days, weeks, I've seen teams lose to bugs. Because they're not focusing on quality, they're not proving their code works. So there is a business model here that you should be encouraging your businesses to look at. So yeah, automate it all, and hopefully it will help prove your code works. And obviously badges, stick the badges everywhere, put them in your READMEs, put them everywhere you can, and hopefully you'll be able to prove your code works. That's me. I hope that was a good first run of this talk, and I hope it provided some useful information.
Woohoo! Well done. Thanks.
Thanks, Rob.
Yeah.
It's really
How's
good.
the timing on that?
Hey, Rob.
Probably it's about 1 hour and 10, I think that was.
Okay, right. That's good to know. Right, I need to cut that down a bit. Probably take about